Hey everyone, welcome back. Let's see problem number 35. This is similar to the last problem. In last problem, we had to return the target if found. The additional part in this problem is if the target is not found, this is the case. If the target is not found, we need to return the index where it can be inserted. For example, target 5. This is similar to the last problem. Target 5 is found at index 2, so we return output 2. In this example, the target doesn't exist. 2 doesn't exist in this array. So we return 1, y1, because the first index is where the target can be inserted. So then the array will be 1, 2, which is the target, 3, 5, and 6. So at index 1, this 2 can be inserted. So that's the idea. And similarly, target 7 is not found here. So target 7 can be inserted at last, which is the fourth index, 0, 1, 2, 3, and fourth index where this 7 goes. So let's take a look at this example. We have this helper flowchart here from the previous problem, so it can help us remember a few things. So the first thing we need to do is identify where we get the mid element. Mid will be calculated by floor value of low plus high by 2. So this low plus high is the low index and high index. Currently, low index is pointing at 0. Let me write the index numbers here. 0, 1, 2, and 3. So low is pointing at 0 and high is pointing at 3. So where would be the mid? Mid would be at first index. And we check, is the mid greater than the target? So target is 5 in this case. Is 5 greater than 3? Yes, it is. So we take this low is equal to mid plus 1. We hit this condition. So we need to update the low. Low will come to mid plus 1. Currently mid is pointing at index 1. So we update our pointer to index 2. And now we calculate the new mid using this formula. Low is pointing to 2 and high is pointing to 3. So 2 plus 3 by 2, which would be 2. Let me bring my pointer on this new mid, which is 2. We check, is target 5 equal to mid? Yes, it is. This target 5 is equal to 5. So we return the index 2. That's why the output is 2. Okay, let's consider the second example now. This time, the target is 2, and let's calculate our mid. Mid will be pointing to this again, because 0 plus 3 by 2 will be 1. So let's point that here. We reach this condition here. Target is less than the mid element. So we make high is equal to mid minus 1. So let's move our pointer here. Mid is pointing to 1. So mid minus 1 would be same as the low. So we point both low and high to the same pointer. And let's calculate the mid again. Now both high and low are pointing to 0. So it would be 0 plus 0 by 2, which would be 0. So the new mid will be pointing to 0 as well. So in this case, low, high, and mid are all pointing to 0. So we check, is target less than mid? Is 2 less than 1? No, it's not. Is target equal to mid? No, it's not. Is target greater than mid? 2 is greater than 1. So yeah, we need to update the low. So the low gets updated here to the next index right here. And if you notice carefully, high came to the left and low went to the right. So remember the while condition last time in the code we took while low less than or equal to high. So if this condition satisfies, then we were calculating the mid within the loop. So in this case, the mid is not calculated again. So we are not going to update the mid. Instead, we now come out of the while loop because both these pointers have crossed each other. And in the previous problem, we returned -1, and that's because we did not find the element. But the problem this time is, where is this target supposed to be inserted to? So if you carefully notice, wherever the low pointer is pointing to, that's where the point where we insert this target. So the array would be 1, 2, 3, 5, 6. So this target 2 comes in the place where the low is pointing to. Let's see how that looks. So I've taken an additional box here. We need to insert this at the pointer where low is pointing to. So let's do that. We will add this right here, and this is where the target comes, this 2 right here. And now the array is sorted. The indices get updated automatically. So our job is to just return where the target is supposed to be if it's not found in this array. So we can say that wherever this low pointing is pointing to, the target comes right in that place. Let's trace this last one for better understanding. So the target is now 7, and let's trace this out once again. We need to find our mid. Mid is low plus high by 2, which is 0 plus 3 by 2, the floor value, which points to here. So we take our mid as usual, and now you know the drill. We check, is this target greater than the mid element? Is 7 greater than 3? Yes, it is. We hit this condition and we update this low pointer pointing to the element next to this mid. So we need to point our low here. We again check 2 plus 3 by 2. The mid would point to right here. So let's update our mid. Once again, we check, is target greater than the mid element 5? Yes, it is. So in this case, we move our low to mid plus 1. So low and high will now be pointing to the same index, which is 3. So I'll update low here to point to high. And now we calculate the new mid. We still calculate the new mid because low and high both are same, and if you remember, the while condition was like low less than or equal to high. So low and high are equal, so we can enter the loop and calculate the midpoint. So we have one more chance to calculate the midpoint. So let's update the mid. Now mid also points to the same thing, what low and high points to. We check, is target greater than 6? It is greater than 6. So we update our low. Remember, this is still happening inside the while loop. So we update it to 1. So we are out of bounds here, but that's okay. Low will be pointing to 4 now. And this time, the while condition doesn't satisfy because while low less than or equal to high, and here we don't satisfy this condition anymore because low is greater than high now. So it comes out of the loop. And what do we return in this case? Like I said, whatever low is pointing to, we return to that. Why? Because if you carefully notice, wherever the low is pointing to, the target has to come to that position. So I can say this target can come and sit like this, where low is pointing to, and low is pointing to 4, and that's what we return. So that's the explanation here. And when we compare the code to the previous problem, the only difference between the previous and this current problem is what we return at the end after the while loop. We actually return where the low is pointing to. So we return low instead of -1. So let's quickly write a pseudocode for this and see. So we'll do low is equal to 0 and high is equal to nums.length -1. We write a while condition here and we check if low pointer less than or equal to high. Until then, we calculate our mid and move our pointers. Once low crosses high, we come out of this loop. So let's take mid is equal to math.floor. I'll just write f here, low plus high by 2. And we need to take these three conditions here. So if target is equal to nums of mid, meaning if we find the target, we return the mid index where the target exists. Else if target is greater than nums of mid, we hit this condition. We get our low pointer to the right side, 1 next to the mid element. So low will be now pointing to mid plus 1. Else, meaning if target is less than nums of mid, we update our high pointer to the left side, 1 less than where the mid is pointing to, so high is equal to mid -1. Now let's trace this for target 5. While low less than or equal to high, 0 less than or equal to 3, so we reach this mid is equal to floor value. So let's update our mid here. So we check, is target is equal to mid element? Is 5 equal to 3? No, it's not. Is target greater than mid element? Yes, 5 is greater than 3. So we update our low is equal to mid plus 1. Let's get our low here to point to the mid plus 1 index. We check this condition. Is low less than or equal to high? Is 2 less than or equal to 3? Yes, it is. So we again check the mid. So we again calculate the mid. 2 plus 3 by 2, which points to 2. So let's update that mid. We check, is 5 equal to 5? Yes. So we return mid. It's all good. So let's trace this for target 2. So we check low, less than or equal to high. Yes. So we update our mid and let's place our mid pointer. So we check is 2 equal to 3. Is target equal to nums of mid? No, it's not. Else if target greater than nums of mid, is 2 greater than 3? No. So we hit this else case. Target is less than mid. So we need to update our high to point to mid minus 1. So we'll update this pointer to point to mid minus 1. Now we check is low less than or equal to high. Since both are pointing to the same thing, we check is 0 less than or equal to 0. So 0 is equal to 0. So this condition is satisfied. So we will update the mid once again. Mid is equal to low plus high by 2. So 0 plus 0 divided by 2, which is 0. So we need to get our mid to the 0th index. We check is target is equal to nums of mid. No. Target is 2 and nums of mid is 1. So this condition satisfies. Is target greater than nums of mid? Yes. So we need to update our low. So let's do that. What is the low value? Low value is mid plus 1. So let's update that. Low value is mid plus 1. Mid is pointing to 0. And we update our low pointer to mid plus 1 to point to index 1. So let's update our low value here. Low will now become 1 and we complete this loop and come back. We check is low less than or equal to high. Is 1, the low index, is less than 0. Is 1 less than or equal to 0? This condition doesn't satisfy. So it comes out of this while loop, right below here. And what do we return now? Wherever the low is pointing, because this target comes and sits right here and all these elements will move to the right. So the position of 2 will be at index 1. So we need to return low. So we return low. So if you notice, this is the only change from the previous code. Previously we used to return -1 here, but now we return low. Okay, let's code this up on the Leetcode. Let low is equal to 0. We are taking the first index for low and high will be nums.length -1. We take the while condition till when we need to run this while loop, while low less than or equal to high. If low crosses high, then we need to exit the while loop. We calculate the mid every time when we are inside the loop. We take math.floor low plus high by 2. Now we need to take those three conditions. If target is equal to nums of mid. Basically, we are checking if target is equal to mid element, then we return mid index. Else if the target greater than the mid element, so we take nums of mid. We update the low pointer to point to mid plus 1. Else, this condition says if target is less than nums of mid, then we need to update our high pointer to point to mid -1. We are moving our high to the left side. So for this code, we can find this target and now we need to worry about insertion for this and this one. So we need to return low here. If target 2 or target 7 is not found, then this loop ends and low will be pointing to the index where we need to put this particular target, 2 or 7 in this case, and then we return that low. So let's try this and the answer is accepted. Let's submit and see if we are missing some edge cases here. No. So everything is good. This is our search insert position. Thanks for watching.